For this sum, in a manufacturing process, 2% of the articles produced are defective. A batch of 200 articles is selected. Giving a justification for your choice, use a suitable approximation. Obviously, they're talking about percentage, so this is a binomial distribution. This is a binomial distribution, and the condition for using a approximation for a binomial distribution is when n is large and p is small. So n is the batch. So the batch n is large and the probability of being defective, the chance of defective items, articles, defective probability of defective is p is small. That's it. But try to write your answer in context. So n is large, p is small. Oh, the sum is not done yet. We have to estimate the probability. So the condition was this, giving a justification. So this is the justification. Now we have to find the probability. Before we find the probability, we always have to define it. So x equals to number of successes. So number of defective articles. Defective articles. So the distribution would be n is 200 and p is 2%, 0.02. So we have to find the probability of exactly 5 defective articles, x equals to 5. But this distribution cannot be used, as we know that in the table we don't have n equals to 200, it's up to 50. For that reason the table cannot be used, so this distribution is useless for us. So in order to do that, we have to use an approximation. We have to use Poisson approximation, because the first target to do is see whether binomial can be converted to Poisson. If it cannot be converted to Poisson, meaning if lambda is more than 10, then we have to go directly to normal approximation. Now 200 into 0.02, 200 into 0.02 is 4. That means lambda equals to 4. We can use the Poisson approximation. Using Poisson approximation, we never use the Poisson approximation for Poisson. Why would we convert Poisson to Poisson? Because it's already Poisson. We only use it for binomial. So we need the value of lambda. Lambda equals to expected value. Expected value is np. N is 200, p is 0.02. That makes it 4. So we change the, we don't have to define it because the definition is here. We just have to name the random variable. So it's y and the distribution is 4, lambda equals to 4. So we have to find the probability exactly 5. Exactly 5 means this time it would be y equals to 5. So for discrete, this means probability of y is less than or equals to 5 minus probability of y is less than or equals to 4. And we have to look up the table where lambda equals to 4. Lambda equals to 4 is here, and we have to find x is less than or equals to 5. So less than or equals to 5 is 0.7851. 0.7851 minus less than or equals to 4 is going to be 0.6288. 0.6288. Now all we need to do is subtract 0.7851 minus 0.6288, and this would be 0.1563. 0.1563. The next question is, estimate the probability there are less than 5 defective. Less than 5 defective probability of x is less than 5 defective, again using Poisson approximation. Remember, we cannot write x because the binomial distribution is defined by x, and the binomial distribution is useless because n is large, p is small. You have to do the Poisson distribution. So probability of y is less than 5, that means probability of y is less than or equals to 4. We can just look up the table. I think we put the value here, that is 0.6288, 0.6288.